Hi there, I'm Joel, and I'm going to be talking about proof of concept delights. I appreciate that that's a little bit of an awkward title. It sounded better in my head, but it is what it is. So one of my favorite quotes is from Linus Pauling, who says that the best way to have a good idea is to have lots of ideas. Most of my life, I've tried to have lots of ideas, although I seem to keep tweeting about the same small handful of them. And another thing I like to tell people is that one working prototype is worth a dozen design docs. A prototype can be interacted with. A prototype can be played with. Prototype can be held in your hands. Whereas a design doc relies on your customers to imagine how things work. Now there's a time and place for design docs, but I like to think that it's after the prototypes. So anyway, who am I, in case you don't know me? So I'm a principal engineer at Capital Group, where I lead a team that focuses on machine learning and data science. Previously, I was at the Allen Institute for AI, where I helped create the Allen NLP library. I believe there's actually another talk at this conference about Allen NLP. You should go to that one. It's a great library, and it'll be a good talk. Before that, I was a software engineer at Google and a data scientist at a bunch of startups. I wrote a couple of books, Data Science from Scratch and 10 essays on FizzBuzz. They're both very good. You should check them out. I'm a mildly successful YouTuber. I mostly make live coding videos, but occasionally I make videos of me playing the piano and singing. You might know me as the person who doesn't like Jupyter notebooks. That's one of my claims to fame, or infamy, I guess. And I have a podcast called Adversarial Learning with Andrew Musselman. Please listen to it. So anyway, I'm going to be talking about proofs of concept. What do I mean by a proof of concept? Here I mean the most minimal thing you can do that demonstrates that your idea sort of works and is sort of valuable. And importantly, is something that's actually usable by your customers. If you can get good at building these, people will think you can work magic. And so today I'm going to talk to you about how I build these, which might be, inspirational for how you could build them. And so here's kind of a contrived example about classifying news articles as to what sites they came from. This is really a proof of concept. I literally spent more time making slides than I did working on the NLP project itself. So it's just an example of something you can do very quickly. Maybe not as quickly as me, but pretty quickly. Okay, so you want to start off by identifying the business problem, choosing a business problem to solve. Ideally, it's something that will impress someone important. So, here in the situation, you have a CEO who keeps getting sent news articles without knowing where they came from. And that could be a big problem for the CEO, who maybe only trusts certain sources or wants to weight them differently or whatnot. And then, this is an NLP conference, and so you'd like to figure out a machine learning or an NLP angle. So in this example, maybe you could build a classifier that takes in the news article and tells the CEO which source this news article is likely to have come from. The next thing you need to do is find a data set. If you're lucky, maybe you already have the data set as part of the problem. Otherwise, you'll have to hunt it down yourself. So I found this one by Googling. It's a data set with a bunch of news articles in it, which is perfect for the problem that I've stated. I downloaded it. And this is what the data set looks like. It's probably too small for you to see, unless you happen to be watching my talk on a giant screen, which you're probably not. But if you had really good vision, you would see that each line has an article ID, a publication date, a URL that it came from, a title, a subtitle, and some text. And so we want to take this data set and say, can we build a model that will take in the article and predict which site it came from? And of course, when you're doing a proof of concept, you probably want to scope the problem down as much as you can. Scope it down relentlessly. You want to solve the simplest, useful version of the problem you can. Here you can say, what if we just started by trying to classify the headline? So there's a lot of text for each article. Obviously, the more text you have, the more problems, the more things your model has to deal with. So as a first attempt, why not try just classifying the headlines? If that works, then great, simple. And this is a little bit idiosyncratic to me, but I pretty much always want a typed representation of my data set. So here you can see I actually made a little Python class to represent each article. The article ID is an int. The publication date is actually a date, and so on. And I really prefer working with my data in this typed kind of way. And I'm a little bit incapable of giving a talk without evangelizing that you should use named tuples. So this is my one slide where I tell you to use named tuples. So why not just use pandas for the data model? Well, a couple of reasons. One is that I do like pandas a lot, and I think it's pretty useful. I tend to find it less useful for NLP data sets because a lot of the time they're not tabular, meaning that you can't represent each instance as a row very easily. You might have multiple labels, you might have part of speech tags, you might have named entity tags, but your each training instance may have various one-to-many features that don't represent themselves well in a pandas table. So that's one reason. The second reason is that I tend to like to add helper methods to my data model, and we'll see this in a couple of slides. Your next step is you want to explore and clean your data. It turns out that this data set that I downloaded has one date time with a bunch of spaces in front of it that doesn't match the dates that are in every other row. And so that broke my parsing code, and I needed to figure that out. Some people will tell you that data cleaning is 80% of data science. For this project, I probably spent about 10 minutes on it, so that definitely wasn't 80% of the project, but I did have to spend a little bit of time on it, not 80% though. And, depending on what you're doing, you probably need your data to be labeled. So sometimes your data comes with labels. This data set, it comes with labels. They're part of the source URL. If you just extract the part of the URL that says what the site is, then you know what the site is. So here's a function that does that. In reality, I probably wouldn't make it a function. I would make it a computed property on that news article name tuple, which is another reason why I like modeling the data that way, is that I can just kind of add computed properties until I'm blue in the face and do some feature engineering that way. Kind of really cheap feature engineering. Or, sometimes your data won't already have labels and you'll need to label it yourself. In that case, there are tools you can use like Snorkel or Prodigy or whatever. I tend to use Prodigy myself, but you use what works for you. If you have to do it this way, get some coffee, because labeling data like this can be pretty lonely and boring. You can imagine going through thousands of articles and having to click on which site they came from. It doesn't seem like a lot of fun, but someone's got to do it, and a lot of the time, that someone is you. And now we don't just want to make the problem as simple as possible when we're doing proof of concept. We want to make the model as simple as possible too. Here, I just started with Spacey's off-the-shelf text classifier and adapted it to my problem. And I'm actually, at this point, I'm pretty fast at taking their off-the-shelf models and adapting them to my problem. I have a pretty good understanding of their examples. That's something you have to build up over time, but it's a good way to get something built and shipped really quickly. And then you can train it. So I trained it. Here is the precision and recall and F1 score for each of the classes in that data set, evaluated on a holdout set. So these numbers are a little bit of a mixed bag. It looks like Huffington Post has really distinctive headlines. You can see there 92% F1. That's pretty impressive. And CNN does not, obviously. That F1 score does not look very good, and which suggests that the CNN headlines are not particularly distinctive compared with all these other sites. And you can see it really varies a lot by site, which is fine. But this was, supposed to be the simplest possible model of the simplest possible problem, and that means that it's, good enough for a proof of concept, if you will. And then your other superpower is to build an interactive demo. So back in the day, I used to have to write React.js to make a demo, and I actually got pretty good at writing React code. but it was still like a real pain, and it would take me like a day to build each demo. Now I use Streamlit for all my demos, and I will show you why in a second. But first, I'm going to show you what my demo looks like. Okay, so our demo is going to be really simple. No fancy visuals, no nothing. The picture is not part of the demo. It's just an example of a headline that was fake news back when a headline being fake news was notable enough that a picture of the headline could get famous on account of it being fake news. Obviously, that's not really the case anymore. So our demo just has a text box where you can put in a headline. And very importantly, you can put in whatever headline you want, whatever headline you can think of. Okay, and you put in a headline, and then you get back the model predictions for the headline from most likely to least likely. So here the model thinks that if you give it a fake news headline like Dewey defeats Truman, that is probably from CNN. So, pretty smart model. You could add charts or colors or whatever. That might be a good idea. I didn't bother. I was happy enough with the table, but obviously some people will be very impressed with charts and colors and things like that. And so I recommend that you do that. And so I mentioned Streamlit before. Why do I like it? Because this is literally the entire code of the demo. It loads the model, it creates a text input box, it runs the model on that text input, it sorts the predictions, and it sticks them out in a data table. So obviously there's a lot of code in the model itself, but this is literally all the code for that demo. So this is super nice. It took me, 10 minutes probably. And so now if you're brave, you let your customers play with the proof of concept. And if it goes well, you look like a genius. And if it goes poorly, well, that was just the first version. It needs some work. This is a good example of asymmetric risk. And so it's a good risk to take. And so what I did was I went to these sites and pulled articles from them that are very recent, from a few weeks ago. So they weren't in the training set, and tried to see how does it do. So here I went to the Huffington Post and grabbed a headline. So these examples are semi-cherry picked. And what do I mean by that? I mean that when I went to the site, I tried to pick an article that looked very prototypical for that site. So I thought, this looks like a Huffington Post article, so I picked it. So it's cherry picked in that sense. It's not cherry picked in the sense that I didn't like run lots of articles through until I got a good result. I sort of picked one I thought I guessed would do well, and then I ran it once. So anyway, you can see this one, losers and suckers. The model is extremely confident that it's from the Huffington Post and gives basically no weight to anything else. So again, we saw that Huffington Post had the most distinctive headlines. That's fine. Here's an article from China Daily about the population report being full of lies. It guessed wrong, obviously. It thought this was DW, but China Daily was its second choice with a low score, obviously. But still, being the second choice is better than being the 8th choice, and giving it some probability is better than giving it no probability. Here's an example from TASS, the Russian news agency, and it is pretty confident that this is a TASS article as well. So that looks pretty good. And, I was hoping that the lorry, which I think means elevator, would be a dead giveaway, that it was BBC. It turned out that that was not the case. Although BBC was the third example, which is good. And, maybe in the RTE is an Irish news site, so maybe they say lorry in Ireland too. So in which case it's less surprising. And, here is a very Irish article. It mentions Dublin's lost department stores. And again, it doesn't get it quite right, but at least the Irish news site it came from is the third choice with some weight and not the 8th choice. So, in each of these, if it didn't get it exactly right, at least it got it, in the top 3. So I'm pretty happy with that for like a simple model on a simple problem that I didn't spend a lot of time on. It already behaves pretty impressively. So you build this, and if you're lucky, your customers like it. And then you can go build the production version, which I'm not going to tell you how to do in this talk, but maybe someone else will give a talk on that. And if not, good luck. And if they don't like it, go build another proof of concept. What's 4 hours between friends? You didn't spend a ton of time on it, so who cares? Having said all this isn't always the right thing to do. If you need to get your recommender model from 0.91 AUC to 0.92 AUC, something like this is probably not going to cut it. If you need to train a trillion parameter language model, this definitely isn't going to cut it. But if you want to prove out a small idea, then this might be the trick. So let's recap. Start by choosing a real business problem, like something that your customers actually care about. Simplify it again, create a real data model, find a data set and figure out how to label it, try the simplest off-the-shelf model you can find, build a demo, highlight the model's strengths and weaknesses, and then decide whether or how to proceed. And so that's how you delight people with proof of concepts. So thanks for coming. I will tweet out the slides that I just showed at my Twitter, which is @JoelGruce. All the code for this project is on GitHub. The link is under Joel Gruce. It's called Proof of Concept Delight, obviously, and you can check it out and see how I did it and play with it yourself. Check out my books, Data Science from Scratch and 10 Essays on FizzBuzz. They're both good. Here's the links to the tools I used. Spacey. I didn't really use Prodigy because the data already had labels, but I did use it to generate the screenshot of how to use Prodigy, so it counts. And Streamlit, and build your own proof of concept, and let me know how it goes. I'm eager to hear if this works for other people as well. So thanks for listening, and let me know if you have any questions.